Let's take a look at the last section here. Implement and manage data platforms. A non-relational database is a database that does not use tabular schema of rows and columns found in most traditional database systems. Instead, non-relational databases use a storage model that is optimized for the specific requirements of the type of data being stored. For example, data may be stored as simple key value pairs, as JSON documents, or as a graph consisting of edges and vertices. Azure Table Storage is a service that stores structured NoSQL data in the cloud, providing a key attribute store with a schemaless design. Because table storage is schemaless, it's easy to adapt your data as the needs of your application evolve. Access to table storage data is fast and cost-effective for many types of applications, and is typically lower in cost than traditional SQL for similar volumes of data. You can use table storage to store flexible data sets like user data for web applications, address books, device information, or other types of metadata your service requires. You can store any number of entities in a table, and a storage account may contain any number of tables up to the capacity limit of the storage account. Azure Cosmos Db is a fully managed NoSQL database for modern app development. As a fully managed service, Azure Cosmos Db takes database administration off your hands with automatic management, updates, and patching. It also handles capacity management with cost-effective serverless and automatic scaling options that respond to application needs to match capacity with demand. Choose from multiple database APIs, including the native core SQL API, API from MongoDB, Cassandra API, Gremlin API, and Table API. Use the Cosmos Db SQL API client library for .NET to create an Azure Cosmos database in a container, add sample data to the container, query the data, and delete the database. Azure Cosmos Db implements the wire protocol for MongoDB. This implementation allows transparent compatibility with native MongoDB client SDKs, drivers, and tools. Azure Cosmos Db does host the MongoDB database engine. Azure Cosmos Db Cassandra API can be used as the data store for apps written for Apache Cassandra. This means that by using existing Apache drivers compliant with CQL v4, your existing Cassandra application can now communicate with the Azure Cosmos Db Cassandra API. In many cases, you can switch from using Apache Cassandra to using Azure Cosmos DB's Cassandra API by just changing a connection string. The Cassandra API enables you to interact with data stored in Azure Cosmos DB using the Cassandra Query Language, or CQL. Cassandra-based tools like CQL-SH and Cassandra client drivers that you're already familiar with. Well, that is, if you are. Scenarios where graph supported the Azure Cosmos DB with Gremlin can be useful are social networks, Customer 365, recommendation engines, geospatial, and Internet of Things. Azure Cosmos DB provides the Table API for applications that are written for Azure Table Storage that need premium capabilities like turnkey global distribution, dedicated throughput worldwide, single-digit multi-second latencies at the 99th percentile, guaranteed high availability, automatic secondary indexing. Applications written for Azure Table Storage can migrate to Azure Cosmos DB by using the Table API with no code changes and take advantage of premium capabilities. The Table API has client SDKs available for .NET, Java, Python, and Node.js. Each physical partition consists of a set of replicas, also referred to as a replica set. Each replica set hosts an instance of the database engine. A replica set makes the data stored with the physical partition durable, highly available, and consistent. Each replica that makes up the physical partition inherits the partition's storage quota. All replicas of a physical partition collectively support the throughput that's allocated to the physical partition. Azure Cosmos DB automatically manages the replica sets. Azure SQL Managed Instance is the intelligent, scalable cloud database service that combines the broadest SQL Server Databases engine capability with all the benefits of a fully managed and evergreen platform as a service. SQL Managed Instance has near 100% compatibility with the latest SQL Server Enterprise Edition database engine providing a native virtual network VNet implementation that addresses common security concerns. SQL Managed Instance provide the ability to lift and shift on-premises applications to the cloud with minimal application and database changes. At the same time, SQL Managed Instances preserve all PaaS capabilities, such as automatic patching and version updates, and automated backups and high availability. Check out the resource on this slide, which include the quick starts, the FAQ page, and also a whole series of Azure SQL for Beginners videos on Channel 9. Highly recommend those. With all these resources, you can pick and choose which parts of implementing Azure SQL databases that you want to review. For the exam objective of configure Azure SQL database settings, there are many possible things to configure, and the objectives just simply do not specify anything more. So we will take a shot at some possible things. I'd recommend that you download the Azure SQL PDF branch as I did and search the keyword configure. In the intro overview for this exam that I did, I showed how to do that. The link is provided at the bottom of the slide also for your convenience. But the key is to then right-click on that page, download it as a PDF, then open the PDF to search only in that PDF of the branch of the docs. That is the best way to hunt for these things on the exam. First, you need to create an Azure AD instance and populate it with users and groups. Azure AD can be the initial Azure AD managed domain. Azure AD can also be on-premises Active Directory domain services that is federated with the Azure Active Directory. Next, in this case, you would associate your Azure subscription to the Azure Active Directory by making the directory a trusted directory for the Azure subscription hosting the database. Each server in Azure, which hosts SQL Database or Azure Synapse, starts with a single server administrator account that is the administrator of the entire server. Create a secondary administrator account as an Azure AD account. This principal is created as a contained database user in the master database of the server. Administrator accounts are members of the DB_owner role in every user database and enter each user database as the DBO user. To grant your SQL Managed Instance Azure AD read permission using the Azure portal, log in as a global/company administrator in the Azure Active Directory and then follow the steps in the link provided. There are 4 main steps to know to configure MFA. First, configure an Azure Active Directory. Hopefully you have that. 2, configure MFA. 3, configure Azure AD authentication. And then 4, download SSMS. On the client computer, download the latest version from Download SQL Server Management Studio, which is SSMS. This link for Failover Group will walk you through the steps and how to create one of those. It is also important to know for these exams the various ways you can secure your Azure databases. This is probably a pretty good bet to review. The picture shown provides insights into the layers of the onion that you need to consider in order to protect Azure SQL. In reviewing this link, you can click through even more links to show the how to configure each of these items. The goal of high availability architecture in Azure SQL Database and SQL Managed Instances is to guarantee that your database is up and running a minimum of 4 nines or 99.99% of the time without worrying about the impact of maintenance operations and outages. Azure automatically handles critical servicing tasks such as patching and backups, Windows and Azure SQL upgrades, as well as unplanned events such as underlying hardware, software, or network failures. When the underlying database in Azure SQL Database is patched or fails over, the downtime is not noticeable if you employ retry logic in your app. SQL Database and SQL Managed Instances can quickly recover even in the most critical circumstances, ensuring that your data is always available. There are 2 high availability architectural models. Standard availability model that is based on separation of compute and storage. It relies on high availability liability of the remote storage tier. This architecture targets budget-oriented businesses applications that can tolerate some performance degradation during maintenance. Premium availability model that is based on a cluster of database engine processes. It relies on the fact that there is always a quorum of available database engine nodes. This architecture targets mission-critical applications with high I/O performance, high transaction rate, and guarantees minimal performance impact to your workload during maintenance activities. When you're using auto failover groups with automatic failover policy, any outage that impacts one or several of the databases in the group results in automatic failover. Typically, these are incidents that cannot be self-mitigated by the built-in automatic high availability operations. The examples of failover triggers include an incident caused by a SQL database tenant ring or control ring being down due to an OS kernel memory leak on several compute nodes, or an incident caused by one or more tenant rings being down because a wrong network cable was cut during a routine hardware decommissioning. In addition, auto failover groups provide read-write and read-only listener endpoints that remain unchanged during failovers. Whether you use manual or automatic failover activation, failover switches all secondary databases in the group to primary. After the database failover is complete, the DNS record is automatically updated to redirect the endpoints to the new region. That concludes our last section of Azure AZ-303 objectives.